Lesson 7 of Sequences and Series. Please subscribe, like, share, and comment. In this lesson, we are working on two examples that are based on the geometric sequence. Now, in the first example, we are required to find the general term of this sequence. That is part A of example 1. And in part B, we shall find the seventh term, and we will be using that general term. All right. Now, let's begin by looking for the common ratio. Remember from the previous lesson, we said R is equal to, say, T2 over T1. And in this case, we have 24 divided by 48. And that gives us 1 over 2. All right. So we have R is 1 over 2. Now, to find the general term of that geometric sequence, we are going to use the formula for the general term of a geometric sequence that says Tn is equal to A R to the power n minus 1. We have R, the common ratio, and we have A, the first term. Therefore, we say Tn is equal to 48 multiplied by R, which is 1 over 2, to the power n minus 1. So we are done with the first part of this example. Now let's look at part B of the example. We are looking for the seventh term of this sequence. All right. So in other words, we are looking for T7. T7. All right. Now we are going to say T7 is equal to 48 by using this general term for this particular sequence, multiplied by 1 over 2 to the power n is 7 in this case. So 7 minus 1. Then we are going to say T7, the seventh term, is equal to 48 times 1 over 2 to the power of 6. And we say T7 is equal to 48 times 1 over 2 to the power of 6. This is going to give us 1 over 64. And then that's going to simplify to T7. Therefore, T7 is equal to 48 over 64. And if you reduce that fraction, you are going to have T7 is equal to 16 into that, you get 3. 16 into that, you're going to get 4. Therefore, we say T7 is equal to 3 over 4. In example 2, we are given the sequence minus 6, 12, minus 24, and 48. And part A requires us to show that this sequence is a geometric sequence. Part B requires us to find the general term of the sequence, and part C, we need to find the eighth term of the sequence. Now let's begin with part A. We need to show that this is a geometric sequence. Let's consider the common ratio. T2 over T1 is equal to 12 divided by minus 6, and that's the same thing as minus 2. Then we are going to look for T3 over T2. T3 over T2 is equal to minus 24 divided by 12. And that's going to give us minus 2. All right. Now let's look for T4 divided by T3. That's going to give us 48 divided by minus 24. And the answer is still minus 2. Now we realize that from the definition of the common ratio, we say R is equal to T2 over T1 is equal to T3 over T2 is equal to T4 over T3, and that is equal to -2. Then we say this has a common ratio, therefore it is a geometric sequence. Now let's look at part B. Part B requires us to find the general term of that sequence. Remember, the general term for all geometric sequences is given by Tn is equal to A, the first term, multiplied by R, the common ratio to the power n-1. Now, to find that general term for this sequence, we are going to say now Tn is equal to A. You remember A is -6 from above there, -6. Then that's multiplying the common ratio. We've just got it, -2, and that's to the power n-1. And that's the general term for this particular sequence. Now in part C, we need to find the 8th term of that sequence. And we are going to use the general term that we have just found from B. We are going to say T8, the 8th term, is equal to -6, the first term, -2, the common ratio, to the power n-1. So 8 minus 1, that's 7. All right. Now it's time for us now to simplify what we have. We say T8 is equal to -6. And you know -2 to the power of 7 is going to give us -128. And when you multiply those two, you are surely going to get T8 is equal to 768. We are done with this example. Thanks for watching. Please don't forget to subscribe, like, share, and comment. Enjoy your day.